On everybody. Today what we're going to be doing is looking at 8.4H, connecting the dots. So please have your notes out, and also what we're going to be doing is take out Desmos on a computer screen or on your phone. If you have a Ti83 or Ti84 calculator, you can also use that. So two things. What we're going to be doing is we are going to be looking at scatter plots and how strong they are. So if you remember from last year, are we talking about something with a strong relationship? Are we talking about something with a moderate relationship? Or are we talking about something with no relationship? So those are the three type of relationships that we're going to be looking at. In order to do that, what we're going to be doing is using technology. So it says in statistics, bivariate data is data that has two variables. The quantities of these two variables are often represented using a scatter plot. This is done so that the relationship, if any, between the two variables is easy to see. So yesterday what we looked at categorical data, that was basically data that was represented by categories. Now we're going to be looking at two sets of numerical data. Okay, so for instance, what is the temperature versus how much ice cream you sell. Or in the example that we're going to be using today is how many hours you study and what your grade is. It's two numerical set pieces of data. We're going to have two variables, an x and a y. So first off, if you have a Ti84 calculator, here is the instructions on how to use it to find the strength of these. So basically what we're going to be doing today is finding the best fit line of these scatter plots. We're not going to just guess like we might have done last year, but we're actually going to solve for it. And we're going to actually look at what's called a correlation coefficient, which describes the strength of our scatter plot. So let's go ahead and look at this. So what we're going to do here is, if you have a Ti83 calculator, Ti84 calculator, please follow along with these steps and you're going to be able to find the data. I'm assuming most of us don't, so what we're going to be doing is using Desmos. So right here, guys, in our warm-up is the set of data we have. So it's basically how many hours did you spend studying for a test and what your grade was. Okay, so as you can see, most likely, the more you study, the higher your grade will go. Now, that's not necessarily a linear relationship, or I should say a direct linear relationship, because it can vary. So let's go ahead and look at this. I'm going to show you how to plug this into Desmos. So I'm going to be separating these into two separate screens. So we have one over here, and then I got my Desmos one over here. So once you open up Desmos, the first thing what we want to do is add a table. So when you hit add a table, you're going to have all your x values. So I'm going to have 4, 8, 3, 795, 6473, and 5. Next, let's go ahead and plug in the corresponding y values. We have 80, 85, 75, 89, 83, 96, 40, 50, 70, 80, and I missed one somewhere, and that's okay, because I did this just in case I messed up when plugging it in. So I have all the correct values now labeled here. And now what we are going to do, let me go ahead and get this off really quickly. Now what we're going to do really quickly is we are going to have these points visible so we can see them. And you can see it's some sort of positive relationship. Let me go ahead and make this full screen. It's some sort of positive relationship, but we can't really figure out where the best fit line is. It'd be going upward. I know I have a few outliers down here, and they're probably pulling the overall grades down. So what we would do is, now this is the part right here of what your Ti83, Ti84 calculator would do. So what we're going to do is basically form a y equals mx plus b equation, but it's going to be a little difference with statistics. This is my data set 1, so we're going to hit y1, so they know I'm talking about this table, and instead of an equal sign, what we're going to do is put this squiggly line. So it's this squiggly line right here. Now in order to get that, you have to hit shift, and then look at the top left-hand corner. You'll see the escape button. Right below the escape button, you can see the little squiggly line. So you have to hit shift and then that button. And then we're going to put mx. Now that x value is talking about the data from table set 1, so we put 1. And we're going to put plus b. Now right here, guys, is my best fit line of this data. So these outliers over here are pulling it down, but now we can easily see the two, okay? So let's go ahead then and look at this with my data. You guys should have your data in front of you, and we're going to go ahead and look at this together. So I already copied and pasted that, so let's go ahead and bring this up. And it says today we're going to explore what the correlation coefficient is, what the R value is. So when we saw that, we had 0.272. And first thing what we want to do, it says, what does the slope mean in this? Well, according to my best fit line, it says for every hour we study, our grade will increase by 2.23%, okay? And then we have this next thing. It says, what is my B? So that was where my M value was right here. And it says, what does my y-intercept mean? What does my B value mean? If I don't study at all, I will get a 60, let's just call it a 62%. Now remember, it's statistics, so it's not, 100% always certain. It's not exactly a linear equation, but based off my data and my best fit line, I should say, that is what I can come up with, okay? So now over here it says connect the dots. So that was our introduction to it. So what we're going to do now is really now explore this idea of this R variable and what it represents. Remember, we're going to be talking about the strength of it. So if I looked at this, my previous one, I had this very low number. It was, what's it called? It was, where's my R? It was 0.271. One thing I want you guys to know is I'm going to have this between -1 all the way to 1. So anything greater than 0 is going to be a positive correlation. Anything that's less than 0 is going to be a negative correlation. The relationship would go down. The closer we are to 1, the stronger my relationship is. The closer I am to 0, it's like a no relationship. And the closer I am to -1, the closer it is to a strong negative correlation. Okay, so we are at 0.27, so that's like right here. So it doesn't look that strong of a correlation between our study and overall grade. So now let's go ahead and look at this data. So we're going to be plugging this in, and so if we were to graph this data, we would go to up over 1, up to over 2.3, up 1.5, so on and so forth. And I would continue to do this, and I'd plot my points here. So you can just start to do that on your sheet. Now I actually already did this on Desmos. So let's go ahead and bring Desmos back up. And I'm going to have this disappear really quickly. And so I already put all these values in here for question 1, and I'm going to make those visible. And here's all my points. We can zoom in. And as you can see, it looks like it's pretty strong correlation, much stronger than the previous one. They're all pretty clumped together. And what we are going to do now is we're going to do the same idea to see what the R value is. So same idea, you can follow those instructions on your Ti84 calculator, or we can do this. So I need the computer to know we're talking about my second data, so instead of hitting Y1, we're going to hit Y2. We're going to make that squiggly line by hitting Shift and the squiggly line, and then MX2, like I said, second set of data, and we're going to do plus B. So when I look at this now, you can see that the lines are clumped a lot closer than they were before to the line. So we would call this probably roughly about a moderate relationship, or excuse me, yeah, about a moderate relationship. It's about 0.5, 0.49, 0.5 it would round to. And so that was pretty generally like a moderate relationship, okay? So when I go ahead and bring this up now, let's go ahead and bring the other screen up. And so when we did this, we came up with a correlation as it was shown right here. And actually, I can just go ahead and write this right here now. It was 0.5. Now it says, using the data set provided by your teacher, sketch the next scatter plot. So we have 3 sets of data plots, and you guys can plot any single one. I'm going to go over one of these really quickly with you. I chose, let's go ahead and look at this. I chose, I believe, the second or the C or D. Let's go ahead and double check. I chose E, actually. So I want you guys to choose a different one than me. I'm choosing E, and if I were to view these now, let me go ahead and hide the rest of this data, hide this line and hide this line. If I were to view this and I plugged it in, I would have this data. And when we look at it, it doesn't look super strong. And they're kind of just laid up all over the place. So I just plugged all this into a new table. Remember how we get that as we go up here, we hit the plus button in table. We just add our values in for X and Y. So when I plug them in over here, I want you to notice that it looks like it might be going down, but it's not super strong. So let's go ahead and find out together what this actually is. So I have Y3 now. Once again, I'm looking at my third set of data. Squiggly line, so shift squiggly line. MX3 plus B. And lo and behold, it is going down. And what we're looking at is for this R squared value. So I will do this one over here. So I already just chose the second set of data and compared it with the one in list 1. So I chose, let's see how this would look for you guys. So for list 1, I already had list 1 written as 2, 2.3, 3.3, 3.7, so on and so forth. And let me go and bring this up just a little bit. Okay, there we go. So these were my values I had here. So once again, I had 2, 2.3, 3.3. I'm not going to write all those, but in the corresponding values, 4.7, 7, 4.2. And when I did all of these, I had a correlation coefficient of negative 0.33. Okay, so on your notes, because I do want you to write everything down, I have the digital version here on Desmos. I want you to write everything down and plot them all, and so you can easily compare. And so go ahead, I want you to pause this video now, and using any one of these sets of data, any one of these other sets of data here, I want you to go ahead and plug this in. The top one's going to be list 1, this will be list 2. And just plug it in and see how it compares. Alright guys, so you should be already done with that now. We're going to be focusing on mine. Now when I compare this, compare your each scatter plot with its correlation coefficient and what pattern do you see. So we kind of talked about this before, and we're going to go ahead and make this bigger really quickly. So the closer we get to 0, the closer our R value is to 0, the stronger positive relationship it is. Okay. If we did this and it says the closer, closer our R value I made a big mistake here. It's closer to the 0, closer to positive 1. Yeah, that was a big mistake, so I'll write in red. Positive 1, the stronger positive relationship we have. Okay, so then let's go ahead now and focus on the closer our R value is to 0, we get closer to having no relationship. And finally, we'll go ahead and do in green. The closer our R value is to negative 1, our relationship is stronger. So the closer our R value is to positive 1, the stronger positive relationship it is. Okay, the closer our R value is to 0, it has no relationship. And the closer our R value is to -1, our relationship is stronger as well. So I just want to do a quick little diagram of these. So if this was this would look like something like a positive 1 relationship. Down here, the 0 relationship would be something like this, like your foot size and your hair length. Doesn't really have a relationship to each other. Then over here, this would be like a strong negative relationship. You draw a really good best fit line there. So complete each sentence. If the correlation coefficient is closer to 0 than the scatter plot, basically what we just went over, the scatter plot is a good relationship, so there is a strong relationship between the two variables. Once again, that would just be something that looks like this. You can draw a really nice best fit line right there. If the correlation coefficient is close to -1, you have a strong negative relationship. So that would look something like this. You might even have a little outlier over there or something. So we have a strong negative relationship. And then finally, if the correlation coefficient is close to 0, then there is no relationship. And your data would look something like this. Okay. So what I want you guys to do now is play around with Desmos and try to create a relationship that has a correlation coefficient in R value of 0.75 with at least 10 points. So let's go ahead now. You can play around with it. What I do with these, go ahead and make this disappear really quickly. So what I did with these on question 5 here, I just already list numbers from 1 to 6 going up by 0.5. And if I just go up like this, and then I go ahead and just have like, I don't know, like 5.3, 5.7, 5.5, 5.8, and then I go down here and then do my equation. One more time, I'm looking at my fourth set of data. So y4 mx4 plus b. I'm looking for something for an R value that's closer to 0.75. So if I just make these a little weaker, so on this last one I make it like a 4 right there. So I just guessed like a 4.2, 4.1, so on and so forth. You can get that closer and closer and closer to 0.75. So I just guessed 4. Now when I look at my data, you can see that it looks pretty consistent, but then it's clumped here, and then I have an outlier down here that brings my data. So right there, guys, I can just go ahead then and just going to copy and paste this down one right here. Oops. So when I do that, I can go ahead and have this be my data right there. Okay. And we can do the same thing now of something with a -5. So now if I want these to go downwards, I want to have an inverse effect. And I want to have a moderate relationship. I don't want to have it super strong like it was that last one. What we can do then is just look at these values. And same thing, it has to be between 0 and 6. So if I have this now then be like 6, 5.5, oops. 5, 4.5, and we're just going to go ahead and label all these, and then we're going to like guess and check them in a little bit. So I already know I got a negative relationship. Now, when we do this, guys, hopefully we notice that this is a really, really strong relationship. Okay, we can already see that. So now when we go ahead and do this, when I add something one more time, I'm looking at y4, and then squiggly line mx4 plus b. We notice that our r value is negative, but it's really strong. We got to make that a little weaker. So let's mess up some of these points. Let's just make this a 6. Oops, a 6. And we'll make this one a 1. And then we can start to see now it's pretty... Oh, I made a 41. Let's make that a 1. And so it's a little weaker. So let's go ahead and make a few more outliers. We can make that a 1 right there. And so now I made it a little too weak, so see how I'm just playing around with it. We can make that a 2 and a 3, and then right there. So that will be a good set of data here. So that's my new table. I was just kind of playing around with it really quickly. And so then when I look at this, you can compare the two sets of data of one that was much stronger and one that was much weaker here. So here's my set of data I can just put right there. So as you can see, guys, when I compare the two, one looks much stronger, one looks much weaker. These points are getting pulled. They're not as close to the center as it was before. So when I looked at this one, you can see on 0.75 with a correlation coefficient, the values were much closer to the line than it would be on this one. Here they're a little bit more spread apart. So if you were to describe what aspects of the data does the correlation coefficient appear to describe, so correlation coefficients are used in statistics to measure how strong a relationship is between two variables. So in this one, it's essentially is how close, so I want you to write this down, guys, and as well as how close are our points to the best fit line. All right, so hopefully this makes sense. If not, be sure to leave questions in the YouTube comments. Feel free to go on Google Classroom, ask me any questions. Feel free to email me. And if not, we will discuss this next time we have our video chats. All right, guys, have a great day.